Alrighty, y'all. So 6.8 deals with increasing, decreasing, and piecewise functions. Let me let one in. Alrighty, so I will start out dealing with the piecewise functions. So y'all, piecewise function is a set of functions used used to find values based on the value of the variable. Here's what I mean. They might give me 2 equations or even 3 equations, and I got to find which interval my x's fall in before I can figure out which equation I'm going to use. So I want to do an example of a real life situation. And I'm just going to have 2 equations on mine, okay? So my first equation, I'll have 15 times x. And I'm going to use this equation if my x is less than or equal to 40. Okay? Now let me figure out my other equation. My other equation will be 600 plus 2250 times x minus 40. And I'll use this equation if x is greater than 40. So let me describe what I've got set up here. I set up an equation based on my pay. So, well, not really, but say I was working at a job, and this is the equation I would use for my pay. I make $15 an hour if my pay is up to 40 hours, right? So $15 an hour up to 40 hours. To figure out my pay, I would just multiply by whatever my x is for my hours and get my total pay. Down here, if you work 40 hours at $15, you're going to get $600. Plus $22.50 would be my overtime pay for any hours over 40. So if I work 46 total hours, 46 minus the 40 would give me 6 hours at overtime pay. I use this equation if my x is greater than 40. So if I work more than 40 hours, I use this equation. If I work 40 or less hours, I would use this equation. So equations I might have, or questions I might have out of this is, what equation would we use if x equaled 25? So what I would do to figure out which equation I would use if my x equaled 25, I got to go over here and look at these domains they're giving me. So 25 is less than or equal to 40. So I would use the equation 15x. And then using that, I would figure out my pay if I was using that to actually do that, okay? So one more question on that one. So what equation would we use if x equaled 40. You know, the same thing, I look at my domains up here. This one said x had to be greater than 40. This one says x is less than or equal to 40. So once again, I would have to use the equation 15 times x. And then finally, what equation would we use if x equaled 50? So now I do got an x value that is greater than 40. So since my x is greater than 40, I would use the second equation, which is 600 plus 2250 times x minus 40. So I do my examples starting out with this pay stuff because most of y'all work a job, and if you work up to 40 hours, you get so much an hour. But if you work overtime, anything over 40, you should get time and a half, which is what I was figuring out on this one, okay? All right, so let me show you some of their examples doing this. So they're giving us f of x is going to equal, now this is going to have three equations. It's going to equal 3x for x less than negative 3. It's going to equal x squared for negative 3 less than or equal to my x less than 4. And then it's going to equal x minus 8 for any x's that are greater than or equal to a positive 4. So y'all, the question they're asking me on this, what equation should be used to find f of a negative 2? So we got to figure out where negative 2 fits in this domain section. Once I know the domain it's going to fall into, I can pick the equation it's going to equal. It's going to equal either 3x, x squared, or the x minus 8. So let's figure out where the negative 2 is going to fall. Negative 2 less than negative 3 is false. Let's see, if negative 2 was here, negative 3 would be less than or equal to negative 2. That part's true. And then negative 2 is less than 4. So negative 2 would fall right in between the negative 3 and the 4. So I would use the second equation, which is x squared. Now at this point, they don't want me to find those values. They just want me to figure out which equation I would use. All right, so another one of those, we're given f of x. And then y'all, this one has 3 of them also. I got 3x for x less than negative 2. It's going to equal x minus 4 for negative 2 less than or equal to my x less than 5. And it'll equal x squared for any x's that are greater than or equal to 5. What equation should be used to find f of 13? So I got to go over here. Let's see, 13 is not less than negative 2, so I can't use that equation. 13 is not in between the negative 2 and the 5, so I cannot use that equation. So then I look at the third one. and it says for any x is greater than or equal to 5, which 13 is greater than or equal to 5. So once again, I would use the x squared equation. So y'all, really the first 3 or 4 of them, that's all you're doing is looking at the system of equations they're giving you and seeing which one you would use, okay? So that's why these are called piecewise function. It depends on your domain for which of the pieces of those equations you use on those, okay? Alrighty, so now we'll get into the intervals. So now we'll look at increasing, decreasing, and constant intervals. So the first thing you got to know on these, you got to read the graphs left to right. Okay, so we got to read them left to right. Makes a big difference on these, okay? So on these problems, when we look for the intervals, we only are concerned with the x values. So we are only concerned with the x values when determining the intervals. I don't care what those y values are. We want to know what parts of our domain or our x values is my graph going up, down, or constant, okay? Now, to be increasing intervals go uphill, left to right. So they go uphill and they have a positive slope. So from left to right, they got to go upwards, okay? Decreasing is going to go downhill left to right, which means it has a negative slope. And it's going to go downhill. So if a graph is going downhill from left to right, that means those y values are actually decreasing as you go through, okay? And then we had constant. Constant is a horizontal line. A horizontal line has a 0 slope. And it's going to go straight across left to right. All right, now 2 more things we got to learn in this section is what we call a relative max. So in the relative max and the relative mins, we are actually looking at y values. So these two deal with y values, and a relative max is a peak in the graph. Okay? The max is the y value for the point. Okay, so these questions you'll say, oh, I got a max of 5 at the x value of 2, okay? So now we're actually going to look at what is the max and what is a relative min or minimum. So the same thing, but this is a valley in the graph. And then once again, the min is the y value for the point. Okay, so intervals, increasing, decreasing, constant. I'm worried about those x values where this is increasing, decreasing, or constant. The relative max and relative mins, I'm looking for the y values and what x value they occur at, okay? So y'all, on some of these problems, I pulled up on the Math Lab because I want to be able to show you the pictures of them. So I'm going to share my screen with the Math Lab homework on it. So I think this is it. Alrighty, so let me move this out of my way right here. So notice they're asking me, here's me a graph, and I'll enlarge it for us. And we're going to find intervals in which is increasing, decreasing, or constant. So the first thing they want to know is increasing. So increasing left to right, this has got to go uphill. And if you notice, this last section over here where I'm doing my cursor is going uphill. So what we want to know is what x values this starts at and ends at. Okay? So this interval is increasing. So let's look at this x value right here. Looks like 1, 2, 3. So it's going to start increasing at the x value of 3 there. And then this arrow keeps going on forever and ever as I go to the right. Remember, I'm following the x's here. As the x's go to the right, the graph is still going uphill. So it starts at 3 and it goes off towards what we say infinity. Now, these always use parentheses. They never use brackets on these, right? Because this 3 right here, it can't be constant and uphill, okay? So starting at 3, curve parentheses to infinity. So we want C on that one. So what'll happen, you'll check that answer. And then it's going to ask us for the next one. It says the function is constant. So constant's where it looks like a straight horizontal line, which is this middle section of my graph. So what I got to do is figure out what x values it starts and ends at. So I'm going to go to the left side over here where my cursor is, and I'm going to go straight down. And y'all, that looks like it's starting at -3 on the x's. And as I go across these x's, it's staying constant until I get to this x value, which was 3. So from -3 on the x's to +3 on the x's, my graph is flat. So let's see, we want -3 to 3. And remember, we got to use parentheses on these, no brackets. All right, so you check that one. And then it's going to come into the last one on decreasing. So the graph is decreasing on this left side. Now I know the arrow looks like it's going uphill, but they just do that because the graph goes forever. This graph really goes left to right, okay? So this graph is coming in on these x's way out here somewhere. So since we don't know where it's starting out here, we're going to say it starts at -infinity because this graph keeps going and going, okay? So we're starting at -infinity and we're going along those x's until we hit this point where my graph stops going downhill. And that point right there would be the -3. So from -infinity until we hit that -3, our graph is decreasing. So let's see, we want negative infinity to -3, and remember we got to use the curvy parentheses. Remember, brackets means that that point would be only decreasing, but at that point it starts constant. So since the point can't really be both of those, we got to use the curves. All right, y'all, you would check that, and then you would move to the next one. So it's going to be good too. All right, if I ever get clicked over. There we go. So this says, let me enlarge this thing a little bit. So what intervals is this function increasing? So I got two parts where it's going uphill, left to right. I got this second little section right here, it's going uphill. And then my third little section over here is going uphill. So let me figure out this first section right here. I need to go up here and figure out what x value that far left point is. So I would go up to here. And y'all, that looks like a -4. So from -4, now remember, I'm going down to x's. My graph is going up. My graph is going up. My graph stops going up right here at the x value of 1. So the first part went from -4 to 1. It was increasing. And then I got to get this part. It starts increasing at, what is that, 7? And notice, by the time I hit 8, the graph is done. So between 7 and 8, it's increasing. So I had -4 to 1 and 7 to 8. So you'd pick A on that one. There's no way it could be C or D because you got two parts where it's going uphill, left to right. And they only had one answer on that, okay? Now what they're doing on this, this right here looks like they're picking Y values and trying to throw you a curveball, okay? So remember, we're only worried about X's at this point. So what interval is it decreasing? Well, the only part going downhill left to right is this third little section. So let's see, it starts decreasing at this X value. What is that? 1, 2, 3. So it starts decreasing at 3. Whoops, let me put my 3. Okay, so I'm decreasing, starting at 3 until I hit this point right here on the X's, which is 7. So from 3 to 7 on the X's, my graph is going downhill. And then constant. So right here is my horizontal line where I'm constant. So this side over here is starting at X value. If I go straight down, I'm at what? -9. So let me put in a -9 right there. And then from -9, you're going across these X's until we get to this point right here. And that was -1, 2, looks like -4. So at -4 on the X's, it stops going straight across. All right, so that interval was what? -9 to -4. Put that in and move to the next. All right, so we better zoom this one up really good, right? All right. First thing they want to know. So the first thing they want to know on this, list the intervals on which this function is increasing. So that's going uphill, left to right. So I got two sections. This little curvy section over here is going uphill. And then section right in the, sort of near the middle right here is going uphill. So I got two sections going uphill. So first I'm going to figure out this one. Now remember, it's going uphill until I get to that X right there. But remember, we go left to right. So we're coming in from negative infinity. So let me put those parentheses up there. So I'm going to start it at negative infinity. So it's going uphill as I cruise in these X's until I hit this point right here where my peak is. So that looks like that's at -7 on the x-axis. Now, I had another place where it was increasing. So I'm going to use my comma and then get my ordered pair again. So let's find that first point of this section. So it's going uphill through this little section right here. So that X value is starting at -2. And notice the graph is going uphill until I hit this point right here, which on the x-axis is -1. So from negative infinity to this -7, it's going uphill. And then from -2 to -1 on the axis, it's going uphill. So you check those. And then it's going to probably ask for which one next? Decreasing. So decreasing is going downhill left to right. And it looks like I've only got one part where it's decreasing. And that's over on this left side. Everything else looks like constant and uphill. So this part is decreasing. So let me go down to the X value where that starts, and that's starting at -7. So let me grab my parentheses, and that was -7. So from -7 on the X's, I go and I go and I go. The graph stops decreasing at this point on the X's, which looks like a -5. Now, we only had the one section that was decreasing, so we check that real quick. And then they're probably going to hit us with constant. So let me get my first parentheses, because I see I got two sections where this is constant on the left side, and then pretty much everything on the right side. So let's figure out this part is constant, starting at the X value of a -5. And it's constant going along the X's until I hit this X value, which was -2. Remember, arrow out of that, put a comma, and then put the next set of points. So it's also constant on this section. So let me find my X's. So it starts being constant again at -1. And then notice this graph goes on and on and on and on as I go out these X's towards positive infinity. Oh, I better fix that. That'll mark me wrong because it wasn't in the blue. All right, I'm in the blue. Now let me put my infinity. So you got to watch this thing. If you have them blue boxes when you put in these answers and it keeps it there, then it'll mark those wrong even though you got it right. Alrighty, so I'm skipping this one and going to the next one because it's got more stuff on it. So I'm going to find relative max or relative minimum, and then the intervals of increasing and decreasing. They didn't want constant on this one because we don't have any, I better minimize just a little bit. I guess I went too big. All right, so there's my picture. Let me try to get it a little better. So it's got a maximum here and a minimum here. So they want to know the relative maximum. The maximum will be from this point right here. Now, it's not the maximum of the whole graph, but it's the relative maximum for this little peak. So we're not talking about the overall maxes. We're just talking about the little bitty max of this peak and then this little bitty minimum of that peak. So the first one has a point -1, 1. So the relative max, remember, is the y value, which will be the 1. And that max happened at the x value of a -1. Okay, so you got to list the max and then what point it started at on the x's. Once you check that, we're going to come in here and do a minimum on these. Ooh, slow internet, y'all. But I got to go through them. So now we want the relative minimum, which is this little valley point right here. So remember, the minimum value is the y value, which is -7. And that happened at the x value of a 3. Okay? All right, so I would check that. So the min or max values are the y's, and we tell what x value they happen at. So now we got to find, I bet, increasing and decreasing, it says. All right, so then you got to hit continue, I guess, for it to keep going. So what intervals is it increasing? So I got this part coming uphill, and then this third little section's going uphill. So let me start with this. And now remember, that graph keeps going forever and ever. So now that I'm talking intervals, I'm talking x values. So I'm coming in from -infinity on my x's. I'm going uphill until I get to -1. So I need a -infinity to -1 to start with. So I got two possible answers. That's a C and D. So what we need to do is figure out what this right part's going uphill. So it starts going uphill at 3 on the x's. And look at that. It's going uphill, uphill forever. So it's headed towards positive infinity. So let's see. -infinity to -1. 3 to positive infinity. We need choice D on that. That 1 to 3 they got there is going downhill, so we can't use that one, okay? All right, then I bet it wants decreasing, because that's all that's left, so I got to hit continue. So it's decreasing on this second little section here. So it starts decreasing at -1, and I'm cruising on the x's until I hit 3. So we needed -1 to 3, which would be C on that one. All right, y'all, so I'm going to go back to my other pad and get into the piecewise functions again. Let me get this fixed up for y'all. So this section ends with evaluating piecewise functions. So when I evaluate these, that's why we had to do the very first part where you had to pick those equations. It was getting you ready to do this here. So the first thing I got to do is determine which domain the x value falls in. Once I know which domain the x value falls in, I will then replace the variable of the equation you chose with the x value. Or how about the given x value? At that point, since these are expressions, we would follow order of operations. And simplify the expression. Oh, y'all, at that point, you're done. So, we're given g of x is going to equal, and this one has two equations, x plus 3 for x less than or equal to positive 1. Then it's going to equal 9 minus x for any x greater than 1. We're going to find three things. We're going to find g of a negative 9, g of 1, and g of 3. So I'll start out with g of negative 9. So first of all, I got to figure out which of these two domains that negative 9 falls in. That negative 9 is either going to be less than or equal to 1, or it's going to be greater than 1. So we know that negative 9 is definitely less than or equal to 1. So we would use the first equation, which is x plus 3. But in place of that x, I got to put the number they want, which is a negative 9. So I get negative 9 plus 3. And then finish that out by adding that negative 9 and 3. We get what? A negative 6. So g of negative 9 equals negative 6. All right, y'all. Then we would find g of 1. So that 1 is either less than or equal to 1, or it's greater than 1. So since it is equal to 1, I would use this equation again, which is x plus 3. This time I'll replace the x with a 1. So I got 1 plus 3, which will give us a positive 4. And then finally we'll do g of 3. So these ain't bad. You just got to figure out which equation to use and then knock it out, okay? So 3 is either less than or equal to 1 or greater than 1. So since 3 is greater than 1, I would use the equation 9 minus x. All right, then let's put into 3. So we get 9 minus 3. And y'all, 9 minus 3 gives us positive 6. All right, so I got one more of these for this section, and then we can move on. So y'all got this one? All right. All right, y'all, this last one, we're given h of x. So let's see, this one has 3 parts. It's negative 2x minus 20 for x less than negative 7. It equals 5 for negative 7 less than or equal to my x less than 5. And then it's going to equal x plus 8 for any x's greater than or equal to 5. So really on these, you got to watch which one's got the equals to them, okay? Now, what I'm going to find h of a negative 9, h of a negative 4, h of 5, and h of 9. So this one, they're coming out with 4 things for me to find. So first of all, I'm going to start with h of negative 9. I got to figure out which one of these my negative 9 is going to fall into. So let's see, negative 9 less than negative 7 is true. So I'm going to use the top equation, negative 2x minus 20. Now, put that negative 9 in for the x, so you got negative 2 times that negative 9 minus 20. Order of operations wants me to multiply before I subtract, so that negative 2 times that negative 9 is a positive 18 minus your 20. And y'all, 18 minus 20 gives me a negative 2. Okay, so main thing on these is just watching signs when you're adding and subtracting. Oh, what's next? H of a negative 4. So let's see, negative 4 is not less than a negative 7. So let's see if negative 4 is in between. So a negative 7 would be less than negative 4. Negative 4 would be less than 5. So I would use the second equation, which says h of negative 4 equals 5. And y'all, since this don't have a variable, we're done. This is what you would call a constant equation. No matter what the x values are, if you're on the x's between negative 7 and less than 5, you're going to equal 5 no matter what. It's sort of like salary pay, okay? So that is 5, and it's done. So what was next? H of 5. So h of 5, if you put the 5 here, 5 is not less than 5. So I got to go to here. If I put the 5 here, 5 is greater than or equal to 5. So since the equals is on this part of it, we would use the x plus 8 equation. Now, this one does have a variable, so I'm going to put the 5 in for the x. And then 5 plus 8 would give us 13. All right, y'all, what was left? H of 9. All right, so let's see. 9 is not less than negative 7. 9 is not in between negative 7 and 5. 9 is greater than 5, so I would use the last equation, which is x plus 8. Replace the x with the 9, so 9 plus 8, which will give me, what's that, 17. Final answer. So piecewise functions, just like y'all do on paychecks, you got 2 equations to figure out your paycheck. Either you got up to 40 hours or you got a paycheck with overtime on it. So y'all know how to do this. You just got to do it with their examples instead of your pay examples, okay? So let me see, so what we're going to do, we'll do our break now, and then we'll come back and finish out with 5.4, and they got some tricky problems on 5.4. So if you're weak at foiling, come around for that one, okay? So let's see, I'm going to pause this for a second.
Almost left you.
We're about to knock out this 5.4. So it'll be the stuff that I was showing you on my bonus. So 5.4 deals with complex, rational expressions. And the only thing we're going to worry about in this section is what we call the difference quotient. So the difference quotient. Basically, this difference quotient is a fancy slope formula. So the difference quotient is f of x plus h minus f of x all over h. So I'll explain how they got this. This f of x plus h minus f of x is like the y2 minus the y1 stuff. Y2 minus y1. The h is the difference in between the x values, which would be like x2 minus x1 would give me that h value. So this is just a fancy sort of slope formula that you can use on any line for any point. Okay, it don't just have to be a straight line to use the difference quotient. So we're not going to worry about how they came up with it or anything. We're just going to work it. Okay, so working the difference quotient, so the people that'll see this again in life are the people that are going to take business calculus or calculus 1 type classes. You'll see this a whole lot in those, okay? So the thing about working the difference quotient, the first thing I got to find is the f of x plus h. So first, find f of x plus h. And finding f of x plus h is just putting a x plus h in for the x's on the function they give us, okay? All right, so once I find f plus x plus h, I'm going to put everything into the formula. So I'm going to put everything into the formula. Because I find f of x plus h, they're going to give me f of x, and then the h is always going to be a h on the bottom, okay? So we're going to put everything into the formula. We're going to work the top. So work the top of the formula. Or how about work the top of the fraction? Because when you put it into the formula, it's going to look like a big fraction. So we're going to work the top of the fraction, which is do that subtraction. Now, once I work the top, I'll have a bunch of stuff over h. I will then cancel out the h's where needed. Well, how about this? Cancel out the h's from each term. So what I'm saying is if you got an h squared in the beginning and then maybe a 2h second, you would cancel one h out of everybody with the h that's going to be on the bottom. Once you do that, you're going to write the result. All right, so that's the main things we're going to do. Find the f of x plus h is the trickiest part of this. Some of these you're going to FOIL, some of these you're going to FOIL and then FOIL again. So let's work some of these. Now there's only 5 in this section, but believe me, 5's enough, okay? So they're telling us for the function f of x equals 2x minus 5. We're going to construct and simplify the difference quotient. Which is f of x plus h minus f of x all over h. So this is one formula you don't have to memorize because they put it on every problem, okay? So here's my function, f of x. So the first thing I got to do is find f of x plus h. So I'm going to put find f of x plus h. F of x plus h is going to equal this function 2 times my x minus 5. In place of the x, I got to put x plus h. So it still looks like 2x minus 5, although my x is now the x plus h. So before I put it into the formula, I got to simplify this as far as I can go. And y'all, the only thing I can do here is remove parentheses by distributing my 2. So I get 2 times x is 2x plus 2 times h is 2h, and then at the end is a minus 5. So I cannot simplify that any further. So I'm going to go to my next step, which told me to put everything into the formula. So the formula is f of x plus h minus f of x. All of that is going to be over to h. I know f of x plus h because I just found it. It's going to be 2x plus 2h minus 5. F of x they gave me was 2x minus 5. All of that is now over h. All right, so now I said work the top. So what's going to happen? Everything in the second parentheses is going to cancel with stuff in the first parentheses. All that's going to be left after you do this step is things that have h's in them. So watch this. This 2x, we're subtracting 2x, so those 2x's are going to cancel. Here you got a negative 5. You're subtracting a negative 5, which is going to make that a positive 5. So that positive 5 will cancel with that negative 5. So what's left? I got a 2h on top over a h on the bottom. So at this point, everything should cancel that does not contain a h. So everything should cancel that does not contain a h. All right, so now at this point I said simplify the h's. Well, this 1h on top cancels with the 1h on the bottom, so that my final answer is 2. Well, y'all, if this is y equals 2x minus 5, the slope of that line would be 2. That's the mx plus b stuff, right? So 2 would be the slope, so when I'm done with that, I better get a 2 for my slope. All right, so let me up it a little bit now. So let's turn up the heat, we say, right? So this one we're going to be given f of x equals x squared minus 4. We're going to find and construct the difference quotient, which is f of x plus h minus f of x all over h. So once again, we need to find f of x plus h. That's going to take the f equation, which is x squared minus 4. In place of the x, we're going to put x plus h. All right, so this one's got a little bit more work because you got an x plus h being squared. So I'm going to go do what I call side work. And I'm going to figure out what x plus h squared is going to equal. Now, when you figure this out, save it for later use because you'll see this more than once in these problems, okay? So x plus h squared, you got to write it twice. X plus h times x plus h. The biggest mistake I get on this is people make that an x squared plus an h squared. But you didn't FOIL it all, so you're going to be missing some stuff if you do that. You physically got to write them and FOIL it. So that x times x is an x squared. X times h is a hx. I'm just putting them in alphabetical order. H times x is another hx. And then at the end, h times h is a h squared. So what you would do to this is add those like terms. So you got an x squared. 1hx plus 1hx gives me 2 hx's. And then at the end is a h squared. I can now put that in for this part. X squared plus 2hx plus h squared. And at the end, I got a -4. So y'all, let's look at this. Nothing is like terms. So I cannot make that any shorter. So now I'm going to plug it in. My f of x plus h minus my f of x will all be over h. All right, we know what the f of x plus h is. They gave me that. X squared. I mean, we figured that out. They didn't give us that. 2hx plus h squared minus the 4. F of x they gave me up here, which was x squared minus 4. So now, remember, everything in the second parentheses will cancel with everything in the first. So the x squared, negative x squared, cancels with the positive x squared. Remember, you're subtracting a -4, which makes it a +4, and that 4 will cancel with that -4. So if you notice, once again, only the h stuff is left. So I got a 2hx plus a h squared will all be over h. So now, everything on top has to be divided by that 1h. So when you take the 2hx and divide by the h's cancel. All that's left is 2x. Over here, you got an h squared divided by h. So remember, if you're looking at exponents, that would have a 1 by it. And when you're dividing variables, you subtract exponents. So h squared over h1, 2 minus 1 would leave me 1h. Nothing else you can do to that, so final answer. So y'all, what makes these trickier and trickier is what we're doing to these functions when we're putting in that x plus h, okay? Notice this one I had to do a little foiling up here to get it all worked out. All right, if y'all got that, I'm going to the next. All right, this one we're given, where'd I go? F of x equals negative 6x squared plus 3x plus 10. And then once again, we're going to construct the difference quotient. All right, so you guessed it. We got to find f of x plus h. So notice this equation now has 2 x's. Each of these x's will be replaced with that x plus h. So you got negative 6 times x plus h squared plus 3 times x plus h plus a 10 at the end. So bring down that negative 6. X plus h squared. I foiled this while ago, remember? In while ago, we said that when we had an x plus h squared, we ended up with an x squared plus a 2hx plus h squared. That's going to be the same thing again, so I'm just going to replace that in here. X squared plus 2hx plus h squared. Then you got plus 3 times x plus h plus 10. So this x plus h stayed the same because it didn't have an exponent outside of that, okay? So y'all look how long this one's getting. Next, I cannot do anything in the parentheses, so I got to multiply by distributing a -6 there and a +3 through those parentheses. Whoa, so let's see what we get. -6 times x squared is a -6 x squared. -6 times 2hx is a -12 hx. -6 times h squared is a -6 h squared. Now I'm going to work on the next one. So that'll be plus 3 times x, which is 3x, plus 3 times h, which is 3h, and then finally bring down the +10. Now y'all want to know what's sad? There are no like terms in that. So since there's no like terms, I'm going to now put everything into my formula, f of x plus h minus my f of x all over my h. All right, so let me fit all that in here. -6x squared minus 12hx minus 6h squared plus 3x plus 3h plus 10. That's my f of x plus h. F of x they gave me, -6x squared plus 3x plus 10. But y'all, we know all three of these are going to cancel with the same 3 over here. A -6 makes that a +6x squared. That's going to cancel with the -6x squared. That's going to make that a -3x. That's going to cancel with a +3x. And then that's going to make that a -10. And that -10 is going to cancel with that +10. So if you notice, every single time, everything in the second parentheses is canceling with stuff in the first one. Oh, so let me see what I got left. I got a -12hx minus a 6h squared plus a 3h. All of that's going to be divided by that h. So now you got to cancel one h from everybody. So -12hx divided by h, the h's cancel, so you get a -12x. Then that's going to be minus 6 h squared divided by h. 2 minus 1 leaves me 1h. And then I got plus 3h divided by h. Those h's cancel, and all that's left is the 3. Okay? So I'll let y'all catch that up, and then we got one more to go. We saved the best for last, I guess you say. All right, y'all, so I'm turning to do the last one. This has f of x equals 3x to the third. Once again, we're going to do f of x plus h minus f of x all over h. Now, don't let this one fool you. Although you just see one little term there, this thing might not be as nice as you think. So, let me show you what I mean. I'm going to find f of x plus h. So that's going to equal 3 times my x, which is x plus h, to the third power. So over here, I'm going to do a lot of side work and figure out what x plus h to the third power is. That's going to be x plus h times x plus h times x plus h. So I'm going to FOIL 2 of these at a time, but guess what? I know what 2 of these will equal. 2 of these is going to equal x squared plus 2hx plus h squared. Because remember, we FOILed this earlier. So FOIL that part. Now, I've got to take this other x plus h times everything in these parentheses. So this one I'm going to actually FOIL out because this is something new. This part we FOILed already, what, twice we've seen that, and it's always going to give you that, okay? So now let's see what we get with this. X times x squared is an x to the third. X times 2hx is a positive 2h x squared. So when you multiply them by the x, all you're doing is adding x's to everybody. And then x times h squared is a h squared x. So I distributed the x. Now I'm going to distribute the h. H times x squared is a positive h x squared. H times 2hx is a positive 2h squared x. So if you notice, all the h's are going up by 1 now. And then let me get more room here. And then finally, h times h squared is a h to the third. Now this one did have like terms. So bring down the x to the third. Hx squareds will add to hx squareds. So 2 plus 1 gives me 3 hx squareds. Now I'm going to do the h squared x's. I got 1 h squared x plus 2 h squared x's gives me 3 h squared x's. And then y'all at the end is a h to the third. So all this work was doing was cubing that x plus h. So now I can put all this in for the x plus h to the third. So I got 3 times x to the third plus 3hx squared plus 3h squared x's plus my h to the third. So that finally, this I'm going to distribute the 3 through those. So y'all watch this. 3 times x to the third is 3x to the third. 3 times 3 gives me 9hx squareds. 3 times 3 gives me 9h squared x's. And then 3 times h cubed gives me a 3h cubed. Finally, I have f of x plus h. So y'all know what would be cruel if I put one on a test and I throw a 4 up there, wouldn't it? Because then you'd have to take all this and FOIL by another x plus h. But hey, I'm not going to do that to you. So let's get this into our formula. F of x plus h minus f of x all over h. Now see what's going to be sad, right? Let's put all this in. 3x to the third plus 9hx squared plus 9h squared x plus 3h to the third. F of x was only a 3x to the third, so only one thing's canceling. This negative 3x to the third will cancel with that positive 3x to the third. All right, so what's that going to do to me? Let's see what's left. 9h x squared plus 9h squared x plus 3h to the third, all divided by h. All 3 of these got to divide by that h. So 9h x squared divided by h, the h's cancel, and I'm left with a 9x squared. Then I do the 9h squared x divided by h. Well, the h squared divided by the h will leave me 1h. So I'll have a positive 9hx. And then here you got a 3h to the third. 3 minus 1 will leave me 3h squared. So if you notice, all that happened, we just take 1h from everybody. Okay? And then that would be my final answer. So y'all, the trick on these is really being able to work the f of x plus h parts, because that's the trickiest part. The f of x they're giving you, and it's always going to cancel out. But you got to get this part right to get these h's right, okay? Because they're the part that's going to actually reduce when you're done, and then be done with those. All right, so let me stop that share. And y'all, that was all the 5.4, so I'm going to quit this video.